To get the derivatives of the trigonometric functions, we are going to use these 6 rules. The first rule is for sine x. So the derivative of sine x with respect to x is equal to cosine x. However, for the derivative of cosine x with respect to x, and that will be negative sine x. You'll notice that these two are partners, okay? For sine x, its partner is cosine x, but for cosine x, it's negative sine x. For tangent x, its derivative is the square of second x. For cotangent x, it is negative square of cosecant x. For the derivative of secant x with respect to x, that will be secant x times tangent x. And for the derivative of cosecant x, that is negative cosecant x cotangent x. Well, these are referring to the derivatives. It doesn't mean that you're going to substitute sine x into cosine x when you're not asked for the derivative. One of the clues that you need to understand when you are solving for the derivative, when this is letter C, so just like cosine, cotangent, cosecant, you will always see negative. So it corresponds to a negative. So let's say the derivative of cotangent x, it's negative square of cosecant x. Cosecant x, it's negative cosecant x, cotangent x. Also, you will notice that when you talk about secant x, cosecant x, it's a product of secant x, tangent x, cosecant x, and cotangent x. The partner of tangent x is secant. Okay, so just like this, it's secant x, tangent x. They are partners. So C and C, cosecant x and cotangent x, are also partners. So you've got to look into different possible ways, possible clues for you to understand and for you to have fast mastery of the different rules. Also, when you are referring to trigonometric functions, you will also talk about the different identities. The ratio identities, reciprocal identities, Pythagorean identities. These are the identities are very helpful for you to simplify your answers. So let's have examples. So we have here our first example, that is we're going to get derivative of sine x minus cosine x. Now take note that we have the operation subtraction here, so it means to say that we are going to subtract the derivative of cosine x to the derivative of sine x. The derivative of cosine x is equal to negative sine x, while the derivative of sine x is equal to cosine x. So you just need to substitute. So therefore, we have the derivative is cosine x plus sine x. So we have here our final answer. On the second example, we have the derivative of 2 secant x plus cosecant x. Therefore, there is an operation plus here, so we have to separate or add the derivatives of these two. The derivative of secant x is secant x tangent x. So we have here the constant 2, so we need to place 2 here. The derivative of cosecant x is negative cosecant x cotangent x. Take note, because this one is letter C and I've told you that we have negative. So lagi silang corresponded. Okay? So do we have the same or like terms here? So we don't see any like terms here. Therefore, we just need to bring down 2 secant x tangent x, and the final sign is minus cosecant x times cotangent x. So that is our answer. The next example, we have the derivative of tangent x plus 3 cotangent x. That is addition, so we need to add the derivatives of the two. We start from getting the derivative of tangent x, and that is the square of secant x. Okay, the derivative of cotangent x, we have letter C here, so it means that's negative. Okay, and there is constant 3 here, so place 3 here using the rule of constant multiple. Okay, so we have negative cosecant squared x. So we now have secant square x minus 3 cosecant squared x. So on this example, we need to get the derivative of sine x, which is cosine x, and the derivative of cosine x is negative sine x. We have to do this because we're going to use the product rule, because it is obviously the product of sine x and cosine x. Okay, now get the derivative of the first term sine x, which is cosine x. Multiply that to the second term cosine x, plus derivative of the second term cosine x is negative sine x. Now multiply that to the first term sine x. So we now have, okay, multiply. So we have minus sine squared x. Remember that we have the Pythagorean identity, which is the square of cosine plus the square of sine is equal to 1, where theta can also be x in the representation, and then that's also 1. Therefore, we can say that sine squared x is equal to 1 minus cosine squared x. We just need to move this one on the other side. Or, if we're getting cosine squared x with respect to sine squared, then we have this. Therefore, we can actually rewrite our answer here. So if we would like to replace cosine squared x into 1 minus sine squared x, and we have 1 minus sine squared x, and that will be minus sine squared x, for us to have the same terms. So we now have 1 minus 2 sine squared x, and this one can be your answer also. However, if you would like to replace sine squared x into 1 minus cosine squared x, then you can have this cosine squared x minus 1. So this will be your first, this is your second. 1 minus cosine squared x. So we now have 2 cosine squared x minus 1. So it is the power of the Pythagorean identities, wherein you can just simplify your final answer. Just take note of the sum of sine squared x and cosine squared x is simply 1. So you can just replace, well, you're going to replace if it is needed. Then if it's not needed, then you're not going to replace. If it is obvious that you can just replace or substitute, then you can do so. The next example is also about product. So we get the derivative of secant x, and that is secant x times tangent x. The derivative of cosecant x is negative cosecant x times cotangent x. Now using the product rule, we now have to get the derivative of the first term, which is sine x, and that is secant x. The derivative of secant x is secant x tangent x. Now multiply that to the second term, which is cosecant x. So we have cosecant x plus the derivative of the second term, cosecant x, is negative cosecant x times cotangent x. And you're going to multiply that to the first term, which is secant x. Now, you can observe here that these two terms have the same factors, secant x and cosecant x. Pareho silang may cosecant x and secant x. So, ang gagawin natin, ilalabas natin yan. So, we now have secant x, cosecant x, times. So, ang naiwan sa first term is tangent x. At ang naiwan sa second term is negative cotangent x. So, minus cotangent x. So, this will be your answer. Now this is also a product rule, so we get the derivative of the first term cotangent x, which is negative cosecant squared x. Now get the second term, which is tangent x, so multiply that to the second term, plus the derivative of the second term, which is tangent x, is equal to secant squared x, and multiply that to the first term cotangent x. So we now have negative cosecant squared x tangent x plus secant squared x cotangent x. And since here you cannot observe any like terms, and you cannot also make use of the other, but you can also observe at the same time, you make use of the Pythagorean identities here, but we can observe here that 1 minus sine x is actually equal to cosecant x, and we know that tangent x is equal to sine x over cosine x. 1 over cosine x is equal to secant x, and cotangent x is equal to cosine x over sine x. Therefore, we can do cancellation here. So we now have, this will now be equal to 1, negative of 1 over cosecant x times 1 over cosecant x. No, that should not be cosecant x. That must be 1 over sine x. So we have to rewrite it. This is 1 over sine x times 1 over sine x, and tangent x is equal to sine x over cosine x, plus this will be 1 over cosine x. Replace it using the reciprocal identity. So dalawa sila because this is square. So cotangent x is equal to cosine x over sine x. So the next thing you need to do is to cancel now. We can now cancel here sine x and sine x, cosine x and cosine x. Therefore, we now have this can now be negative 1 over sine x is equal to negative cosecant x. Ibalik natin sa itsura niya, sa katumbas niya. And here, that will be 1 over cosine x, which is secant x, plus 1 over cosine x is equal to secant x, and 1 over sine x is equal to cosecant x. So here we can observe that the answer is 0. From this case, you will appreciate the identities. Notice that cotangent x is actually equal to 1 over tangent x. Therefore, when we get the product of 1 over tangent x and tangent x, it is actually equal to 1. So this can be written into the derivative of 1 with respect to x, and the derivative of constant is simply 0. So may I advise you that you just need to observe first the identities. Who knows? Those are just simple problems and you're making it complicated because you don't know the identities. So observe the identities first. On this next example, you notice that this is simply tangent x. Okay. Therefore, this is also equal to the derivative of tangent x with respect to x. So the answer is simply the square of secant x. So you don't exactly need to go through the division rule because this can just be replaced by tangent x. So the answer is simply secant squared x. On this problem, we cannot use the identities because there's nothing common between them, and we cannot do any elimination when we use the derivatives or the identities. So we use the quotient rule. So we need to square the denominator, so the square of tangent x. Now get the derivative of the numerator first, and the derivative of the numerator secant x is secant x times tangent x. Now copy the denominator tangent x minus the derivative of the denominator tangent x is equal to the square of secant x, and now copy the numerator secant x. The next thing we need to do here is to observe if we can bring out or there's something common with them, and we observe that these two terms has secant x, so we can bring out secant x and multiply that to tangent x times tangent x is tangent squared x, okay, minus secant squared x over tangent squared x. Now on this problem, we can observe that we can observe that we can make use of the identities, which is Pythagorean identities, that is 1 plus tangent squared x is equal to secant squared x. Therefore, we can say also that tangent squared x, when we subtract secant squared x, the difference is -1. It's just a matter of moving the position. Therefore, we can substitute or replace tangent squared x minus secant squared x into -1. So we have secant x times -1 over tangent squared x. Now, we can observe that secant x and tangent squared x, now we combine and we have negative secant x. So we just need to distribute -1, so negative secant x over tangent squared x. Actually, this is accepted already. However, if you would like to go through and look into other identities, and we might as well simplify this one. So let's take a look on other identities and let's try to simplify negative secant x over tangent squared x. Since we know that secant x is equal to 1 over cosine x, and we know also that when we get the reciprocal of this, balik natin dun sa taas, magiging itsura niya is negative secant x, okay, and that will be cotangent squared x. Why? Because we can actually rewrite this one into negative secant x and multiply that to 1 over tangent squared x. And 1 over tangent squared x is equal to cotangent square x, or the square of cotangent x. Now, we also know that cotangent x is equal to cosine x over sine x. And now we have secant x is equal to 1 over cosine x. Therefore, we can rewrite this into -1 over cosine x, multiply that to 1, that is cosine x over sine x, the quantity is squared. Therefore, if we expand the square of cosine x over sine x, then we can cancel out cosine x here, right? So expanding that will give us, so when we expand -1 over cosine x, and from the square of cosine x over sine x, which is the equivalent of cotangent squared x, pag i-expand natin yan, nagiging ganito ang kanyang itsura. Okay, so dito obvious na pwede natin i-cancel ang cosine x here. Therefore, ang matitira ay we have -1 over sine x times cosine x over sine x. And we know that cosecant x is equal to 1 over sine x, right? So we can now rewrite that into negative cosecant x, and cosine x over sine x here is cotangent x. Or you can actually differentiate secant x over tangent x by knowing the identical expression for this, or it's another form. Notice that secant x is also 1 over cosine x, and 1 over tangent x is cotangent x. So we have 1 over cosine x. Replace cotangent x to its ratio identity cosine x over sine x. Cancel cosine x, so we now have 1 over sine x. And 1 over sine x is simply cosecant x. It's reciprocal identity. Therefore, we can replace secant x over tangent x into cosecant x. And the derivative now of cosecant x is negative cosecant x, cotangent x. Then that makes it even easier with the use of the identities. So on this next example, it is also a quotient rule. So we square the denominator. Now get the derivative of the numerator, which is negative cosecant squared x, and multiply that to the denominator cosecant x minus the derivative of the numerator cosecant x is negative cosecant x times cotangent x. Now multiply that to the numerator cotangent x. Okay, now we can observe if there are like terms here. So we now have pareho silang may cosecant x, right? So pwede natin ilabas ang cosecant x. So we have cosecant x factor out times negative cosecant squared x plus, kasi this is minus and minus, so you can have positive as the final sign. So plus cotangent x times cotangent x here is the square of cotangent x over cosecant squared x. Now the identities, Pythagorean identity for cosecant and cotangent, we have 1 plus cotangent squared x is equal to cosecant squared x. Therefore, cotangent squared x minus cosecant squared x is equal to negative 1. So we can replace this 1 into negative 1. So we have cosecant x times negative 1 over cosecant squared x. Okay, so we have negative cosecant x over cosecant squared x, and that will be negative 1 over cosecant x kasi pwede natin mag-cancel. Then matitira na lang is cosecant x kasi that is square. And negative 1 over cosecant x is actually equal to negative sine x. So the answer is negative sine x. It really matters that you are good in the identities. Remember that the first presentation is a long method. However, if you're critical enough, you know already that we can actually factor this out. We have 1 over cosecant x times cotangent x. Also, because 1 over cosecant x is equal to sine x, that is the ratio identity, and cotangent x is equal to cosine x over sine x. Therefore, we can cancel out sine x here. So what is left is cosine x. Therefore, this can now be reduced into the derivative of cosine x with respect to x, which is simply negative sine x. We got the same answer actually on the first presentation. Okay, so what I want you to do is to always be critical and always take a look on the different possible identities, and you'll know that those are just simple problems. This is also a quotient rule. 1 over cotangent x, when you get the derivative of this, the answer is the derivative of 1 is simply 0. So we have negative of negative cosecant squared x, which is positive cosecant squared x. However, the derivative of sine x is simply cosine x. Now we're ready for the substitution. This is now equal to, using the quotient rule, square the denominator sine x, so we have sine squared x. The derivative of the numerator is cosecant squared x, so we have cosecant squared x. Multiply that to the denominator sine x minus the derivative of the denominator is cosine x, and then you multiply that to the numerator 1 minus cotangent x. We distribute, so we now have sine x times cosecant squared x minus cosine x. So distribute, cosine x times 1 is negative cosine x, and negative cosine x times negative cotangent x is positive cosecant x cotangent x over the square of sine x. So this is your answer. Also, when you're asked to evaluate, just take note evaluating function is simply substituting the input to the given function. Let's say we have f of x is equal to negative 2 sine x, and you're asked to get f prime of pi. So again and again, that is f prime. So it means to say you're going to get first the derivative of f. So the derivative of function f is f prime of x, is equal to negative 2 times the derivative of sine x, which is cosine x. So we now have negative 2 cosine x. So from f prime of x, let x be equal to pi because you're asked to do so. Therefore, we have f prime of pi is simply negative 2 times cosine pi. And cosine pi is equal to negative 1. So we have negative 2 times negative 1, and that is 2. I just don't need to elaborate that pi over 2, pi over 3 because we've been doing that since pre-calculus. We also did that during our midterm. So please, your calculator must be set in radian and just go through the values. It's all about evaluating. Okay, let's have another example. Another is, let's say g of x is equal to cosecant x, or let's say x cosecant x. So that is the product of x and cosecant x. So let's make use of, let's say you're looking for g prime of pi over 4. Okay, let's have this. Since this one is a product, so we need to get the derivative of x. The derivative of x is simply 1, and then you multiply that to the second factor cosecant x. Now get the derivative of the second factor cosecant x, and that is negative cosecant x cotangent x. Okay, but the operation here is addition. Then multiply that to the first factor x. So we now have cosecant x minus x cosecant x cotangent x. They have the same factor, or these two terms have the same factor cosecant x. So bring it out. So we have cosecant x times 1 minus x cotangent x. So this is already the derivative. Now we're ready to get g prime of pi over 4. This is pi over 4, so we substitute that. Now to get the answer, we know that cosecant x is actually equal to 1 over sine x. Therefore, when we get sine pi over 4, our answer here is 1 over square root of 2, which is square root of 2 over 2, right? Therefore, cosecant pi over 4 is simply the reciprocal of sine pi over 2, and that is 1 over sine pi over 2, or pi over 4, and the answer is square root of 2. Therefore, if we're going to solve now g prime of pi over 4, using now this function, this will now be square root of 2 times 1 minus x is pi over 4, so substitute, and cotangent pi over 4 is simply 1. So we have square root of 2 minus 1 over pi over 4. So this one can be your answer already, or you can have square root of 2 minus pi square root of 2 over 4, or square root of 2 minus square root of 2 pi over 4.